Hello, welcome. We are in lesson 7.1. We're continuing our properties of powers in this video, so we're going to jump to the page starting with 0 exponents. If you haven't watched the first video on power to a power, multiplying and dividing, go ahead and check out that video first. All right, our fourth property is going to be 0 exponents. Now, 0 exponents are a little bit tricky to understand, but basically what this is anything to the 0 power is really just going to equal 1. Our shortcut is that anything to the 0 power is equal to 1. Now you might say something to the 0 power should equal 0, but in this case it actually cancels to 1. And we'll take a look at an example of why that's the case. So here in example 1, 9 to the 0 power is 1. If you don't believe me, feel free to check that on your calculator. But typing that on our calculator, we would know that anything to the 0 power, even 9 to the 0 power, is equal to 1. Now, example 2 kind of shows why that happens. If you remember from our previous video, when we're dividing powers, we subtract our exponents. And if we subtract 2 minus 2, we'll get 0. Now, this is actually equal to 1. Our answer is not 0. We don't just write nothing. We should write 1 as our answer. That's because we know when we divide anything by itself, we just get 1. 3 divided by 3 would be 1, or 10 divided by 10 would be 1. X divided by x would be 1. So when we subtract and we get a 0 exponent, that's really just equaling 1. Similarly, with multiplying, we learned in our last video that our shortcut for multiplying is we add our exponents. 7 plus negative 7 would also be 0, which again, we know would equal 1. Now, you might say then whenever we see a 0 power, we just write 1 as our answer. However, we have to look carefully at what we're actually setting to the 0 power. For example, in number 4, this W is the only thing that has a power of 0. This 0 does not apply to the negative 5. This would actually be negative 5 times W to the 0 power, which really it's just W to the 0 power that's equal to 1. This is really negative 5 times 1, which is just negative 5. Another way we could think about this is that W to the 0 is really just going away, and we're left with the negative 5. All right, our last property is negative exponents. And I think out of the 5 properties, negative exponents are probably the trickiest to understand. So to kind of understand how a negative exponent works, we're going to use division to help us figure that out. Now, here we have x to the negative 3 power. And I'm actually going to rewrite this as x squared over x to the 5th. And if we remember our property for dividing, when we're dividing, we subtract our exponents. So if I do 2 minus 5, 2 minus 5 gets us negative 3. So this is in fact equal to negative 3 because 2 minus 5 is negative 3. Now, if we think about what this means, if we have an x squared means we're multiplying 2 x's. And if we have an x to the 5th, that means we're multiplying 5 x's. And one of the things we talked about was when we have a matching pair, when we have an x on top and bottom, those will actually cancel. Now, what ends up happening is we're actually left with 3 x's. But those 3 x's are on the bottom of a fraction. That means when we write our answer, we need to put those x3, the 3 x's, or the x cubed, on the bottom of a fraction. Now, you might ask, well, what goes on top? And if we don't have anything on top, we could just put a 1 up there. So that would become my answer. So our shortcut for this is a little bit tricky to understand, but to take a negative exponent and to make it positive, we're going to take what we call the reciprocal. Hopefully you've heard this word before, but reciprocal really means that the power will switch places in the fraction. Now, here's kind of how I actually do this shortcut in practice. When I have a negative, I know we want to make that negative positive. We're not allowed to have any negatives in our final answer. So what I do is I make a fraction and I switch that power in the fraction. So if it was on top, we're going to move it to the bottom. So for example here, I'm going to use this as kind of my fraction bar. We'll move that x cubed to the bottom, and again, we could just put a 1 on top. Sorry, that cubed should be a cubed, not a subscript. So I'll just change that really quick. And that should be an x cubed. All right, we'll do a couple examples to kind of see how negatives work. So here we have a y to the negative 6. Now we might say that's fully simplified, but we're not allowed to have negatives in our answer. So I'm going to create a fraction and we're going to move that to the bottom. The y goes with it. So on my fraction, we'll put y to the 6th on the bottom. When we move it to the bottom, it becomes positive, and we'll just put a 1 on top. That would be my answer. Number 2, we have a 4 to the negative 3, which again, to simplify that negative, we're going to create a fraction and we're going to move that power within the fraction. So on the bottom, we'll put 4 to the 3rd power. And again, we can just put a 1 on top. Now, just like before, when we have a number here, we could actually find that number. So I could do 4 times 4 times 4, or 4 cubed, which would be 64. So my answer would actually be 1 over 64. We're just going to leave that as a fraction. You might be tempted to type it on your calculator and get a decimal, but we're just going to leave it as a fraction. All right, now we're going to get a little more complex because we don't always just have a 1 on top. Whenever we have a negative, it's not always going to be a 1. The thing that we want to be careful of is we only want to move the base that has a negative exponent. So in example 3, I see this 2, and 2 does not have a negative exponent. This exponent is only applied to the x. What that means is in my fraction, 2 is going to stay on top. 2 is not moving at all. Similarly, this y to the 5th is also positive. And if it's positive, we don't have to do anything with it. That's just going to stay y to the 5th. The only thing that's going to move is the negative. X to the negative 2 is negative, so that's what we're going to move. We only move the base with the negative exponent. So that would move to the bottom. When it moves to the bottom, that becomes positive. Now, we could leave that as our answer. Typically, we'll write things in alphabetical order, so I'll just flip that and I'll write x squared y to the 5th. So for example, if you're ever checking my answer keys, you might see those in alphabetical order, but these are essentially the same thing. All right, we'll try our last example here. Now, you see some negatives, and in all of our other examples, we've moved those right away. However, when we start combining our other properties, my recommendation is to do all the other properties first, and then if you have any negatives at the end, move things in a fraction. So for example, here I see this negative 2 is outside of parentheses, which this means it's a power to a power. So typically what we do is we distribute that power to all of our bases. 4 is a base. 4 is not an exponent, so 4 is going to stay as a base, and it's going to get a power of negative 2. For the b here, our shortcut when we had a power to another power, when we were distributing, was to multiply. So if I multiply negative 2 times 3, we'll get negative 6. And then c, we would also distribute, and again, we'll multiply. Negative 4 times negative 2 is actually going to turn to a positive 8. Now, I've distributed. I can't really combine anything here, so now we can go ahead and make our negatives positive. To do that, we're going to create a fraction, and I'm just going to make one big fraction for all of these terms. But just like I said, we only want to move the negative bases. So 4 has a negative power, which means we're going to move that. And B has a negative power, so we're going to move that. But C does not have a negative power, so C is going to stay on top of our fraction. And we're going to move the 4. When we move the 4, that becomes positive, and we're going to move the B. And when we move the B, that also becomes positive. Now we have all positive exponents in our answer. Our last step is we could just change this 4 squared. That is a number, so we could do 4 squared. 4 squared is 16, so I'm just going to rewrite that as 16, and that will stay in the denominator. And that would be our answer. Now, if you want to flip, we'll just do a couple examples of combining all of these properties together. So we'll see that with some of these, we have a lot of steps. So if you want to take a look at these 4 examples, we'll just combine some of these properties together. I'll give you some suggestions as to how to do that in the easiest way. In number 1, I see we have some parentheses and we have an exponent outside of the parentheses. My recommendation is to distribute exponents first. So this 3, I'm going to distribute, and we have to apply it to everything in the parentheses. 2 is a base. 2 is not an exponent, which means that 3 is going to become an exponent on the 2. It also becomes an exponent on the x. It also becomes an exponent on the 3 because the 3 is not an exponent. Again, that's the base. And it becomes an exponent on the y. Now, the y already has a power of 2, so our shortcut when we were doing a power to another power was to multiply. So 2 times 3 is 6. Now, we can't combine our x's and y's, so we're just going to leave those. But these numbers we could simplify. So we could actually do 2 to the 3rd power. 2 to the 3rd power is 8. And we could actually do 3 to the 3rd power. 3 to the 3rd power is 27. We don't have any negatives here, so we're good. We can't do anything else to simplify. That would be our answer. Number 2, kind of a similar situation. I see here we have some exponents outside of the parentheses. So we're going to go ahead and start by distributing. Now, this 2 only applies to the first set of parentheses. So I'll go ahead and distribute that 2 to every base in the first set. This 2 out in front is not an exponent, so that power of 2 is going to become a power on that base. Same thing with the c. C doesn't have an exponent, so we'll put that power of 2 there. And the d, we know our shortcut is to multiply, so 4 times 2 will be 8. We'll move to our second set of parentheses. This 5 is an exponent, and we'll have to distribute it. Neither of these bases have powers right now, so that will become c to the 5th and d to the 5th. Now, if we look here, we have a couple things that we could simplify. One is I could actually do 2 squared. 2 squared is 4. And we're nowhere allowed to combine like bases. So the c's we could combine. Now we're multiplying. So if we're multiplying, our shortcut is to add our exponents. So if we add 2 plus 5, we'll get c7. And the d's, we're multiplying. So again, we can add our exponents. 8 plus 5 would be d13. And that would be my answer. Number 3, again, we have division here. Our shortcut for division is to subtract our exponents. Now, I do see that we have a negative, but I'm going to go ahead and wait until the very end to deal with that negative exponent. And I'll go ahead and simplify what I can to start. Now, this 2 over 8, those are not exponents, so we would just divide those. However, if I do 2 divided by 8, I'm going to get a decimal. I'm going to get 0.25, and we don't want any decimals here. We can have fractions, but we don't want decimals. So if I get a decimal, I'm just going to leave this as a fraction. Really the only thing that we could do there is we could simplify that and we could make it 1 over 4. So instead of 2 over 8, I could change that to 1 over 4, but I can't divide those, so again, I'm just going to leave that. Then we can subtract our exponents. When you subtract, by default, it's just going to go on the numerator of this fraction. So anytime I subtract, I'm just going to put that on top of my fraction. 4 minus 7 is going to be negative 3. And if we do our y's, negative 4 minus 3, be careful of your negatives, negative 4 minus 3 is negative 7. However, we don't want any negative exponents in our answer, so we're going to move the negative bases to the denominator. 1 is not negative, so 1 is going to stay on top. The x will move and the y will move since both of those are negative. So in my answer, 1 will stay on top and 4 will stay on the bottom. We'll move the x and it will become positive 3. We'll move the y and it will become positive 7. That would be our answer. All right, final example. Again, I see a lot of negatives here. I'm going to do all of my other properties first and wait until the end to move my negatives. This negative 2 is going to have to be distributed to everything. So we'll start with the negative 4. The negative 4 is not an exponent, so that's going to stay a base, and it's going to get a power of negative 2. For 6 is an exponent, so we can multiply. That's our shortcut. 6 times negative 2 is negative 12. The b's will multiply. Negative 3 times negative 2 is 6. And the c's, 0 times negative 2. 0 times negative 2 is just 0. Now, one of the properties we learned was that anything to the 0 power is equal to 1, which really means that c is just going to go away. It's technically being multiplied by 1, but we know multiplying by 1 doesn't change anything, so I don't really need to write that 1. I do see some negatives, so we're going to move anything that's negative to the denominator of our fraction. So this negative 4 has a negative exponent, so that will move. A has a negative exponent, so that will move. B does not, so B will stay. And like we said, C went away. So on top of our fraction, we now have a b to the 6th. And on the bottom, that negative 4, one thing we want to be careful of is only the exponent is changing. This negative 4 will stay negative 4. Only the exponent is changing. And a will become positive 12. My very last step, this is a number here, so we could do negative 4 squared. The thing we'll want to be careful of is we're doing negative 4 squared. So if you type that on your calculator, make sure to use parentheses there. That should become a positive 16 when we simplify that. And that would be our answer.